ideal gas begins at a volume of 9 liters and a temperature of 750 Kelvin. The temperature of the gas decreases to 375 Kelvin, and we're going to try to determine the new volume of the gas. So again, the first thing that we're going to do is we're going to underline the important information. So it begins at a volume of 9 liters and a temperature of 750 Kelvin. We see a new temperature indicated by the Kelvin, that unit, and we know that we're being asked for a new volume. So this will be our question mark. So now that we've underlined all the important information, we're now going to identify the givens and the unknowns. So initially, we're going to call that our T1. We have 750 Kelvin. And our V1 is at 9 liters. We also see that the gas decreases to a different temperature. That will be our T2. And that will be 375 Kelvin. And again, I already put a question mark. That will be our V2. And that's our unknown. So we are trying to find V2. So that gives us our identify the givens and the unknowns. Now we need to determine the equation our law to use. So remembering that Charles brings the TV to the party, we're going to use Charles's law in this example. So Charles' law is V1 over T1 equals V2 over T2. So again, one volume at a given temperature is directly related to another volume at a given temperature. So plugging in, we're going to get we're going to get 9 liters over 750 Kelvin equal to some volume over 375 Kelvin. So, to solve this, we need to get V2 by itself. We're going to multiply by 375 Kelvin to both sides. Notice that the kelvins will cancel out, leaving us only with units of liters. So I'm now going to rewrite this. We have 375 Kelvin. Sorry, Kelvin's already disappeared. By 9 liters, all over 750. And that's equal to our V2. So now, we're going to pick up a calculator. We're going to plug in our numbers. So we get 375 times 9 divided by 750. And we get that our new volume, so our V2, is equal to 4.5 liters. Notice that through each step, I carry the units along with me, and it makes sense because the liters are a unit for volume. Now to double check our answer, we said that temperature and volume are directly related. So we see that temperature goes from 750 to 375, meaning that it decreased. We would also expect, because of the direct relationship, that the volume would decrease from 9 liters to something smaller. In this case, because the temperature is halved, 9 liters is also halved, and gives us our final answer of 4.5 liters as our new volume.